Algebras. Welcome to your Chapter 5, Lesson 1, Day 1 notes. I'm just going to do a quick overview of what Chapter 5 will entail in general. So, Chapter 5 is all about systems of linear equations and inequalities. We are going to be solving graphically and algebraically. So, we'll start with graphing systems of equations day 1 today. There'll be a day 2 where it's kind of like looking at graphs of a line and something else, like a line and absolute value, or maybe a line and a quadratic, and just looking at what are those intersection points, okay, and those answers. So, 2 days talking about this. Then we will solve systems of equations algebraically using the substitution method in lesson 2 and the elimination method in lesson 3. We'll talk about what equivalent systems look like. And basically, that'll just be manipulating equations so that we can get answers that check out for both equations. Then, of course, a review and a quiz. Then I know it says there's 3 days of notes. I will go through and assign which days I want to do in lesson 5. We don't need to do all 3 days. So we'll look at word problems. And then lesson 6, there are 2 potential days. That will depend on how well we go through graphing linear inequalities. If we have to do the second practice, okay, 1 day of notes, maybe a second practice. Same with systems of inequalities. There'll be 1 day of notes, maybe a second practice. And again, that will depend on how well we're doing with the first day if I assign those. And then we're going to talk about graphing systems of inequalities word problems, because those have a tendency to appear on the Regents exam. And then, of course, exam and cumulative review, right? So here we go. Let's start with lesson 1, day 1. I'm just going to do something else real quick, which is pull my whole pile out. There we are. So lesson 1, day 1 notes. First thing we're going to do is just talk about what the answer is when it comes to a system of equations. And a system of equations is 2 lines that meet at a single point. And that single point answers both equations. It is their intersection point, okay? So if a point checks out on both lines, then that is the intersection point that these lines will be. Because lines have a constant rate of change called a slope, they will only meet in one spot, if ever. And that's something I'll come back to, okay? So what I'm going to do to check to see if this is an answer or a solution to the system is I'm just going to plug in its x and y value into each of these different equations and see if it works out. If it works out in both, then it is the system. It is the answer to the system. Okay, so my x value is 4 and my y value is 1. So 4 plus 2 times 1 gives me 6, right? Well, yeah, 4 plus 2 is 6. So it checks out. So it worked in the first equation. So now I'm going to try it in the second equation. 4 minus 1 equals 3. Is that correct? Yes, it checks out. So 4, 1 is a solution to that system. Okay, let's try this one. All right, so here's my x, here's my y. 2 times negative 1 plus 5 times 2 equals 8. 2 times negative 1 is negative 2. 5 times 2 is 10. And negative 2 plus 10 is indeed 8, so it checks out in the first equation. Let's check the second one. 3 times negative 1 minus 2 times 2 should equal 5. Well, let's see. I get 3 times negative 1 is negative 3. And 2 times 2 is 4, so minus 4. Uh-oh. Negative 3 minus 4 is actually negative 7. Is that equal to 5? No, this does not check out. This is not a solution to the system. It has to work in both lines. So that point needs to be shared by both line equations. Okay. So when you are solving a system, a linear system graphically, you put both lines on the graph and you label each line and you label their intersection point if there is one. And again, I'll get to that in a second. Most of the time there is one. Sometimes there might not be, right? Parallel lines, they never meet. It's such a shame because they have so much in common. Huh. Good joke. In order to graph our lines, we need y equals mx plus b form, right? So I'm going to graph these two lines in two different colors. Okay, here's going to be my first one, and here will be my second one. Okay, so let's start by getting y equals mx plus b form for the aqua one. It's going to mean subtracting that 2x over to the other side. So y equals negative 2x plus 8, which means my slope is negative 2 over 1, and my y-intercept is 8. And so I come over here to my graph. Y-axis, let's go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And my slope is negative 2 over 1, so down 2, right 1. And of course, if I can't fit any more down 2 and right 1s, I go up 2 and left 1. But hold on, I'll get there. So I go back to the y-intercept, up 2, left 1. Now, when I graph a linear system of equations, I actually plot that many points, as you just saw. I don't know where the other line is going to be, but I do know that if it meets, it's going to meet at a point, and it's going to be one of these points. So I make sure I plot as many things as I can for the first line that I'm graphing. Then, of course, I use a straight edge to draw my line, arrows at the end because there's no domain limit. I'm going to hold off labeling because I don't know where the other line is, and I don't want my label to interrupt my graphing. So I'm just going to hold off labeling, put my blue aside for 1 sec, and I'll come back to it. So now let's get the red into y equals mx plus b form. Right? Only thing I have to do is add that x over. And I get y equals x plus 2. Well, this means a slope of 1 over 1, because that's the number in front of x right here. There we go. And a y-intercept of 2. So that means go to the y-axis at 2. And now count up 1, right 1. And you can see heading here, and I'm just going to put a couple more up 1, right 1s back this direction. But you can see where that intersection point is. So now I don't have to plot as many points for the second one because I've already found that intersection point. So I graph until I find that, and then I take my straight edge, connect, cover the whole graph because there's no domain limits, arrows at the end because there's no domain limits. And now that I know where each of those lines are, I can go and do my labels. So there's lots of labeling that happens here. We label the original equations with their equation. So each line gets the equation, right? I use y equals mx plus b form, as you guys already know from chapter 4. I'm just a big fan of y equals mx plus b form. So that's what I use to label here. You can use the original or y equals mx plus b form. That's a total choice up to you. But red and blue make purple. Even though it's a trash color, I'm going to use it. This intersection point is shared by both lines. So this needs to be circled and labeled 1, 2, 1, 2, 3, 4. So 2, 4 is the answer because it is shared by both lines. You need to circle it and label it. Circling it indicates to me that you know that's the answer. Labeling it indicates to me that you know what the x and y coordinates of the answer are. I usually also write it off to the side like this. Okay. There we have it. That's how we graph a system and label everything. We never draw a straight line without a straight edge. So a ruler, you know, the side of a binder, side of a piece of paper, side of, I don't know, plan book, right? Something, a cardstock, an index card, something with a strong edge that you can use to graph. Okay, let's look at a couple more examples. Whoa, we got a couple more examples for sure. That's my homework. Okay. I'm going to do example 2 here. Okay. I'm going to color code again. First one's going to be blue. Second one's going to be red. Let's get y equals mx plus b form to start. 2y equals 4x plus 8. Well, the x term is already over to the other side. I really just need to get rid of that 2 in front of the y. It's currently attached by multiplication, so let's divide everything by 2. Okay, so I get y equals 2x, because 4 can evenly divide by 2. So I get 2 in front of the x, and then plus 4 over here. That means that my slope is 2 over 1, and my y-intercept is 4. So I head over to my graph. I find an y value of 4 on the axis. So 1, 2, 3, 4. That's where I start. So 0, 4. And now my slope tells me to go up 2 and right 1, up 2, right 1, up 2, right 1, because this is my first line I'm really plotting, right? Now that I've gone up 2 and right 1, let me go backwards and go down 2 and left 1, because notice 2 negative moves still create this positive sloped line here. But again, I'm plotting as much as I can, because I don't know where the other line is going to go. And so because I don't know where the other line is going to go, I want to really make sure I have this nice and straight and on my points, so that if it intersects with one of those points, I know where it is. I'm not going to label yet. I'm going to hold off on labeling my blue. And I head to my red. And the only thing I really need to do for red to get y equals mx plus b form is I need to subtract that x over to the other side of the equal sign. So I get y equals negative x plus 1. So my slope is the number in front of x. It's negative 1 over 1. And my y-intercept is the 1 at the end. So I go to the y-axis. I plot the point 0, 1, which is my y-intercept value. And now my slope says down 1 and right 1. And as I can see, going down 1 and right 1 actually moves me away from where I could potentially intersect. So let's go back to the y-intercept and do the opposite, which is up 1 and left 1. And notice that still gives me this negative sloped line, because I still made one negative move, but what it really does is intersects with the other line. So again, I don't have to plot as many points for this one, but I do have to cover the graph, use a straight edge to draw the line, arrows at the end. Now I can start all my labels. So I've got y equals negative x plus 1 as my red line, and I've got y equals 2x plus 4 as my blue line. And now I need to, red and blue make purple, circle and label this intersection point, which is negative 1, 1, 2. So negative 1, comma 2, just like that. And that is my answer for the intersection point of these two lines. Now, I can also check my answer using my graphing calculator. So here's what I'm going to do now is I'm going to scooch this off to the side just a little bit, make my graphing calculator just a little bit larger, and I'm going to plug these two lines into y equals. So I press y equals. My y1 happens to be blue and my y2 happens to be red, so that's how I'm going to enter them. I have to have y equals mx plus b form to enter these into the graphing calculator anyway, so it's good that I found that, right? So the y equals mx plus b form of the blue line is y equals 2x plus 4. So 2x plus 4 goes in y1. Then I just arrow down to y2, and I'm going to type this one in. This is negative x plus 1, but negative is this little guy under 3 if it starts your function. So negative x plus 1. Notice both functions are on because their equal signs are highlighted. And now if I press graph, I'm going to see both of those lines. Are those correct? Yes, those match up with what I have. Now look where that intersection point is. Let's double check to make sure that intersection point is what I found. Here's how you do that. Press second and graph. What I want you to notice is this starts at 0 because I had recently reset this graphing calculator. So I have to arrow up and down to change the X values. Now I'm going to press graph again just to go back to the picture. Where do I think the y-intercept or the intersection point is? -1, 2. So what I can currently see on my tables is not in the negatives at all. So I have to arrow up to see that point I'm looking for. And look at that, -1, 2 is on both of my equations. It's on both of my tables. That means that point is shared. And if you notice all the other points, that's the only one that they share. That is the answer. That is the intersection point. That is how I can check my answer using my graphing calculator. Okay? Now, I just want to show you something that I had casually mentioned earlier. Okay? And what I had casually mentioned earlier is that not every pair of lines will have an intersection point. If the pair of lines does have an intersection point, it's one intersection point. However, not every pair of lines does intersect. So instead of doing the problem on 3, what I'm just going to do is show you 2 parallel lines on 3. Okay? My first line that I'm going to graph is going to be y equals -1/2 x plus 3. Okay? Slope of -1/2, y-intercept of 3. So I go to the y-axis, 1, 2, 3. My slope is down 1 and right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. And notice I do that as much as I can because this is my first line. So I go back to the y-intercept and do the opposite. Up 1 and left 2. Up 1 and left 2. And I do that plotting as many points as I can fit. There was no domain limit, so I cover the graph. I use my straight edge to draw the line, and I put arrows at the end. Okay. Not going to label yet because I don't know where the second line is going to go. But what I am going to graph of the second line is y equals -1/2 x minus 6. So you'll notice about these 2 lines that they have the exact same slope. They do have different y-intercepts. So what I'm going to do is I'm going to head down to -6 on the y-axis. 1, 2, 3, 1, 2, 3, 4, 5, 6. And then -1/2 is down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. Well, okay, let me go back and try up 1, left 2. Up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. There we go. Up 1, left 2. And then graph. So hold my straight edge up, cover the whole graph, arrows at the end. Now, because lines have a constant rate of change, a slope, if you have 2 lines with the same slope that do not have the same y-intercept, they will never meet. We call these lines parallel. These are parallel lines. And parallel lines do not have a solution to their system. These 2 lines do not have a shared point ever because they will never touch each other. They will never meet. But my little joke that I made earlier, right? It's too bad because they have so much in common. What do they have in common? Their slope. Because they have the same slope, they'll never meet. So that commonality is the reason that they will never intersect. Okay? So I just wanted to make sure you saw that as a possibility. okay, in what you're looking at. There's another possibility. There's another possibility. And I'm just going to show you what that other possibility is on question 4. So I'm not going to do the system that was given to me. I'm going to make one up for you and just show you there's one more thing that could happen here that doesn't result in one intersection point. And here is the line I'm going to graph. Y equals 2x plus 3. So my y-intercept is 3, and my slope is 2 over 1. So up 2, right 1, up 2, right 1. And I can't fit any more of those, so I'm going to come back and do down 2, left 1. And of course, hold up right here. Straight edge, cover the whole graph, arrows at the end, hold off on labeling, right? Hold off on labeling, wait till I'm done. What if my second line is what if my second line is negative 4x plus 2y equals 6? Well, it currently is not in y equals mx plus b form. So I got to move things around to make it y equals mx plus b form. So let's add 4x to both sides. Get 2y equals 4x plus 6. Okay, now to get rid of that y in front of the 2, I divide everything by that 2. So when I do that, this cancels out and leaves me a 1y, which is my goal for y equals mx plus b form. The 4 over 2 in front of the x, well, 4 divides by 2, and it leaves me 2x here. And then over here for the y-intercept, I get 6 divided by 2 is a plus 3. Now, whoa. What's my y-intercept? 1, 2, 3. What's my slope? Up 2, right 1. Up 2, right 1. Up, are you seeing what's going on here? Or down 2 and left 1, and down 2 and left 1. And look what's going on here. If I use my straight edge to connect these points, what has happened? These end up being exactly the same line. So once they didn't start out with the exact same equation, but when I had them both in y equals mx plus b form, they ended up being the exact same line. And so because of that, this is the same line, and it means that you have solutions. Every single point on these two lines is shared. Every single one, in both directions, into infinity. So your options here for potential number of answers are one intersection point of the two lines. 90% of the time, probably 99% of the time in here, this is what happens. But possibility wise, you might get two lines that are parallel, so they never meet. They have no answers in common. Or you might get the same exact line, which means every answer is in common, and we call that infinite solutions. So the number of solutions you could get to a system of lines is 1, none, or all. Okay? Just so you're aware of other possibilities. The vast majority of the time, this is what you are going to see. Because the whole point of what I'm looking for here is, can you graph two lines on the same coordinate plane correctly? And can you find their intersection point? And can you label everything? And can you understand why this is the answer? So the majority of the time, this is what I'm looking to test. But again, these other situations could occur. So be prepared for parallel or same. Okay, be prepared for all. Anticipate, but be prepared for all situations here that I've shown you. Okay? Alrighty, guys. This is it for graphing systems of equations. Good luck. Let me know. We're going to talk about some other situations like these tomorrow and shared solutions and what that might look like. But we're going to start with you doing these graphs yourself. Be very mindful of using a straight edge when you graph straight lines. Do not do that freehand. That is not acceptable. Okay? Make sure you're labeling. I'll be seeing you guys.